Hey guys, so welcome back to your next class of catalyst concepts. Today we are going to look at another form of energy. Okay, so in the previous class we looked at what is kinetic energy, how do we calculate it, and we looked at certain sums based on kinetic energy also. Today we look at another form we call as potential energy. Okay, now what is this potential energy? Now we know kinetic energy is the energy possessed by a moving body. But what if there's a body that's not moving, but it still seems like it has some form of energy in it? Okay, then what do you see? And if it's not moving, where is the energy coming from? That's the question, right? So let's take an example of a simple bow and arrow. You know what's a bow and arrow, right? So this is a bow. It looks kind of like this. It will have like a string or whatever on here, and then you have an arrow which looks kind of like this, whatever, right? And then you just put it in the string of your bow and you stretch it, and then you throw it out, right? So when you stretch your bow out, it kind of gets like elongated, right? The bow is going to stretch forward and the string will stretch backward, kind of like this, and the arrow is placed somewhere here, right? Once you do that and you release it, you'll see that the arrow is going to just like fly forward, right? It's something that you must have seen in a movie, or you must have might have tried it your own self also. Okay, so why does this happen? Okay, why exactly is this happening, and why if I just put an arrow in the bow and drop it, it's not going to fly, it's just going to fall down? Okay, this is exactly what potential energy looks like. Okay, so potential energy is energy gained by an object through change in either the shape or position of an object. Okay, so if you change the shape or the dimensions of an object, or you change the position, if you just put it somewhere else, then this energy that is gained is called as potential energy, right? In the bow and arrow example, you are changing the shape, right? When you're changing the shape, you yourself are going to give your own energy from your hands and you're going to stretch it, right? You kind of stretch it out, because then energy from us is transferred to this bow. So the bow, which initially had no energy, is gaining more energy, right? What does it do with that energy? It has to give it out somewhere. That is why the moment we leave it, it tries to give the energy off to someone else, which is nothing but the arrow. Okay, that is how change in shape can create some sort of an energy. That is because it is getting energy which has to go out somewhere else, as simple as that. Okay, there are other examples of potential energy also. For example, rubber bands. Okay, I think you must have at some point just played with rubber band, right? You kind of stretch it and you just leave it and it starts flying. Okay, shouldn't do that, it will hurt your friends. So but however, we still do it. Uh, yeah, so that rubber band stretching is also a form of potential energy. You use energy to change the shape of the rubber band, stretch it, and once you release that, the stored energy in the rubber band gets released. It comes back to its original shape, but the energy kind of makes it fly, right? So that is one form of potential energy that talks about shape. Now let's talk about change in position of the object. Okay, this is more common for us. Say for example that you're standing here on the floor, there is a shelf. I think this one example we looked at before. Say you have like a box on the floor. You kind of like want to put it on top over here on the shelf, right? If I see, I have changed nothing but the position of this object from the floor all the way to the top, right? I've essentially increased the height at which it is placed from the ground to maybe like a few feet above or a few meters above. Okay, this change in position also creates a sort of an energy. Okay, that object on the top layer, or a topper, a higher level, has more energy than the box over here. That is why a falling object is going to definitely hurt you. The moment it falls, it's going to fall and it's going to affect you in some way, rather than an object that hasn't fallen from that much height, or an object that is like really close to the floor. Obviously, the one on the floor is not going to hurt. So this is also another form of potential energy gained by the object. Since you put energy, you work against gravity, put it up top, all that energy gets stored in that object. Okay, and it's released once it moves down. Okay. Now, this is all about potential energy's definition. Now, what about how do I calculate this potential energy? If I have to calculate energy, we already know that work done is nothing but the energy, right? How much work we do to change that energy is this energy. So, say for example, let's take this case wherein an object is moved from one position to another position through a height h. Okay. Now we know that work equals to force into displacement. Very clearly, we know that the displacement is nothing but the change in position. So I'll say work equals to force into height. Okay, height is nothing but how much distance between this and this. Now, what is this force? Okay, now we know one thing. Force is nothing but mass into acceleration, m into a. So I can write work as m into a into h. Now this acceleration, which acceleration? We are not really accelerating the body. However, we work against the acceleration due to gravity, right? Which is the downward force that pulls an object down. So if I talk about the acceleration here, I will say A is nothing but G. So I'll say M into G into H. Okay, just remember that point. We are going against gravity. So the acceleration is against acceleration due to gravity. So I'll say work equals to m into g into h, or simply w equals to mgh. Not mdh as in the masala, this is mgh. Okay. So if I have to calculate potential energy, I'm going to use this formula. Let's go with a very simple numerical. Okay, so I'll say a box is placed on a 2-meter shelf from the ground. Okay, find its potential energy if box weighs let's say 4 kilograms. Okay, so this is a very simple numerical over here. I'm asking you to find the potential energy. Okay, so over here potential energy is nothing but, like we just said, mgh. Okay, so we'll use the same formula. Let's start with the given first. What's given to us? They've told us the mass of the object. It's nothing but 4 kilogram. Okay, now just remember mass has to be in kilogram. If it's in grams, please convert it to kilogram. Okay, G is something that they'll either mention in the question. If they don't mention, just take it as 9.8. Okay, for the sake of simplicity, I'm going to take it as 10 meters per second square. Okay, now let's say G equals to 10 meters per second square, and H equals to, height is given to us, so nothing but 2 meters. Right, so height has to be in meters. Okay, remember meter per second square, and kgs. So my potential energy is simply M into G into H. It's nothing but 4 into 10 into 2. 4 tens are 40, 40 into 2 is 80. So my potential energy is nothing but 80. But 80 watt, right? What is the units for this potential energy? Since it's energy again, we'll have the same units as any other form of energy or the form of work, right? We know work is nothing but energy same. Since it has the same units of work, I'll use the same units, that is nothing but joules. So I'll say the potential energy for that box is nothing but 80 joules. Okay, it's a very simple formula and a very simple type. All you need to do is figure out which variable they need you to find. If they don't give you H and they give you potential energy M and G, you simply just substitute it, cross multiply, and find the correct answer. Okay, so that's it for today. I'll stop here. If you have any questions, comments, doubts, please drop them in the comments below. And I'll see you again in the next class. Thank you very much and bye-bye.